Welcome to The Explainer. Today we're diving deep into a clinically significant oral bacterium, Prevotella dentalis.
Now, just so you know, all the information and data we're about to cover was compiled using Gemini Deep Search. If you want to dig into the primary literature yourself, the full list of sources is in the notebook, and that's linked right down below. Okay, let's get into it.
So here's our game plan. We're going to start with an overview of the organism itself. Then we'll head to the lab bench to talk identification. After that, we'll see how it all connects to the patient, the diseases it causes, treatment guidelines, susceptibility, and finally, how we handle infection control.
First things first, let's get properly introduced to our microbe of the day. What is Prevotella dentalis, and what's its place in the grand scheme of things? Okay, the first concept you absolutely have to grasp is that Prevotella dentalis is a classic pathobiont. You know, it's one of those organisms that's perfectly happy to just hang out as part of the normal flora, but given the right opportunity, say a shift in the microbial community or a weakened host, it can flip a switch and become a real problem. So what are its key features? Well, it's a gram-negative coccobacillus. It absolutely requires an environment without oxygen. It's an obligate anaerobe. And it's probably most famous for being a team player in those complex, messy, polymicrobial infections we see in the mouth, things like periodontitis and dental abscesses. You know, its taxonomic history is actually a perfect little story of how microbiology has evolved. It started out named Prevotella dentalis, based on what it did in a test tube. But then, once 16S RNA sequencing came along, we got a look at its genes, and that placed it right where it belongs, in the Prevotella genus. A great example of genotype trumping phenotype. All right, let's move from the textbook to the lab bench and talk about how we actually find and identify this thing, from old school cultures to modern tools. So, if you're working a plate, here's what you're looking for. It's a bit of a slow grower, and you need to give it strict anaerobic conditions. A key trait is its sensitivity to bile. It won't grow on BB agar, which is a great way to help differentiate it from the Bacteroides fragilis group. And unlike some of its relatives, it doesn't produce any pigment. And here's the bottom line, and it's a really important one. Just relying on traditional biochemical test strips and panels, well, it can be a recipe for misidentification with these guys. Which, of course, begs the question. In a modern clinical lab, what's our gold standard for getting a confident, accurate ID? And that brings us to the two heavy hitters. On one hand, you have 16S rRNA sequencing. It's the reference method, for sure, but this genus has some tricky heterogeneity that can muddy the waters. On the other hand, you have MALDI-TOF mass spec. For routine work, it's the go-to. It's fast, it's accurate. Its only real kryptonite is the quality of its reference database.
Okay, we've identified it in the lab. Now let's connect the dots back to the patient. What kind of trouble does Prevotella dentalis actually cause? Its home turf is really the mouth. It's a key player, a ringleader, really, in the biofilms that drive pretty much all the major oral infections. Everything from infected root canals and periodontitis to deep cavities. But, and this is a huge but, its impact doesn't necessarily stop at the gumline. This is where that concept of the oral systemic link becomes so incredibly important. Exactly. Prevotella dentalis has been pulled directly out of serious deep neck space abscesses, and there's even data linking it to systemic inflammatory conditions like rheumatoid arthritis. It's a stark reminder that the mouth can absolutely be a source for infections elsewhere in the body. So we understand the pathogen, we know the diseases it's involved in. That naturally leads us to treatment. Let's take a look at the therapeutic strategies.
Now, this is where it gets really interesting. Let's look at the Dutch approach, which has a very strong focus on antimicrobial stewardship. The first principle is always mechanical source control. Drain the abscess first. Antibiotics only come into play if there are systemic signs of infection. And even then, look at the choice: narrow-spectrum amoxicillin, a short 5-day course. It's a really targeted, smart strategy. And this comparison really lays bare a key difference in philosophy. The Dutch guidelines are perfect for those localized, drainable infections. Broader international guidelines, on the other hand, are often designed for more severe infections or situations where you're more worried about resistant copathogens being in the mix. And for kids, well, the principles are exactly the same. Source control is king. But the crucial difference is that all antibiotic dosing must be strictly weight-based. Amoxicillin is still the first choice, with clindamycin being that key alternative for allergies.
Of course, any discussion about treatment is incomplete without talking about resistance.
So let's take a look at the antimicrobial susceptibility profile for Prevotella dentalis.
So its biggest built-in weapon is producing beta-lactamase, which takes out penicillins. But what's really concerning is the rise in acquired resistance, carried on mobile genetic elements. We're seeing specific genes pop up that confer resistance to tetracycline, clindamycin, and even metronidazole. This is why knowing your local antibiogram is so important.
For the definitive word on susceptibility, we turn to the EU-CAST breakpoints. This table gives us the hard numbers. This is the data we use to interpret those lab reports. That MIC, or minimum inhibitory concentration, tells you exactly what it takes to stop the bug from growing. This is absolutely essential for guiding therapy when you're dealing with a serious or a non-responding infection.
Okay, last but certainly not least, let's zoom out from the single patient and talk about the crucial topic of infection prevention and control.
In any setting where this organism lives, especially dental clinics, you have to have a rock-solid, multi-step approach to instrument processing. It's just not negotiable. You categorize your instruments, you meticulously clean and then sterilize them. And this is the part people sometimes forget. You have to routinely monitor your sterilizers with biological indicators to prove the process is actually working.
All right, we've covered a lot of ground, and your expertise is invaluable to us. To help us make these briefings as useful and accurate as possible, please leave your feedback and any questions you have in the comments below.
And if you found this useful, be sure to subscribe for more deep dives into the microorganisms that really matter in clinical practice. Thanks so much for watching.